Hello, everybody. I want to welcome all of you guys to this CodeLabs Tech Talk. Today we're going to hear from Mo, who has 5 years of experience in senior and lead roles and is going to talk to us today about testing.
Hello. Let me go ahead and start sharing screen real quick. Okay, cool. All right. As was mentioned, my name is Mo. I'm a software developer at Bishop Fox currently, but over the last couple of years, I've worked in DevOps, software development, and most notably, I've worked as an SDET, which is a software development engineer and test. That means I'm kind of this mix between quality assurance and development. This talk is intended to be kind of a nice primer to testing. Testing is actually a very kind of deep field and has a lot you can do with it. The goal here is to kind of give you a nice introduction to it and give you an idea of why you'd want to test, how you could go about it, and what benefits you get from doing so. This will not be very technical. There will be some code here and there that we might go over, but nothing major. Really what I expect from you going into this is maybe know a little bit about how functions work in Python or any language really, and maybe a little bit about object-oriented programming. The terms that I use here can be a bit overloaded in some places, so don't be surprised if you go do your own research after and you find that the terms we use here might be used a little bit differently in other places, but I'll do my best to define them for this talk so that you know what we are talking about in the context of this talk. Finally, if you have additional questions at the end, we'll go over those, or if you'd like to talk in more detail about how you'd go about implementing these things and what they would look like in a real world scenario, feel free to reach out to me. Really, the two best ways to get in touch are either through Discord. I've put my Discord username on the slide, and I will link it at the very end, or by email. That's also available. Feel free to reach out. I'm always happy to answer questions about this. So before we get started, I want to quickly go over kind of, and I'm realizing right now that you always realize this when you start presenting. I'm realizing I'm missing a slide. But I want to quickly go over why you might want to test. The obvious reason is I've written some code and I want to verify that that code works, right? Additionally, I might want to also make sure that the features that I've written, the functionality of the code I'm writing actually works. So if it does the underlying stuff of like, I've made a new record, does that properly go into the database and all that? Does the actual underlying functionality that I care about, that I wrote the code for, actually do what I think it does? I also maybe want to be sure that I can interact with other services properly. I can write files to disk properly. These are all things that I'd be interested in testing, and I would normally maybe do manually. But the problem with that is after you do a couple manual verifications of your code base and it starts getting bigger and bigger, it starts to get harder and harder to verify everything. So the way around that is you start writing automated testing. And once you start doing that, you have to start thinking about, okay, how do I verify different parts of my system? I want to verify that I can, I want to prove that my thing works. How do I go about doing that? And that's kind of what we're going to be looking into today. So one useful construct that we kind of work with when we're talking about testing is the concept of a test pyramid. For our case, we're going to be looking at a 4-tiered test pyramid with, but just note that there are lots of other types of layers that you can put into this, depending on what you're interested in validating. Like one example that we don't have listed here is maybe performance testing or security testing, are things that I might also be interested in that are kind of a little bit more complicated. So we're leaving them out for the sake of this talk. But these are kind of a good baseline to get you started. They give you a lot of depth and a lot of reassurance that your system is working the way you think you think it is. So first layer is unit testing. This is probably the one, if you've heard of any kind of testing, this is probably the one you've heard most about. This lets us verify individual blocks of code. So this is for verifying my functions work the way I expect them to. It's for verifying that my objects and my classes are doing what I think they're doing. And it's very nitty gritty and logical. And we'll go into these in more detail in the next coming slides. But as a high level, that's what unit tests are for. Next, we have component tests. We will define what a component is momentarily, but a component test allows us to verify functionality. So this is I'm not so much interested in the individual code blocks. I'm interested in that when I string those code blocks together, when I string my units together, do they do what I want them to do? Is the actual business value being delivered? Next, we have integration testing. This is verifying that my component can talk to other components or the system or services that it might need. And then there's system level testing, which is, can I take my component and put it on the end system that I need it to be? So can I install it, or can I make sure that I can write to disk, those kinds of deals. So with that, let's start talking about unit testing. So for kind of to kind of start talking about this, we need kind of a dummy example to work with. So this is pretty much one of the most basic functions you can ever write, right? It's an addition function, takes two parameters, adds them together, and gives you back the value. So when we're thinking about how to validate this, it helps us to kind of think of things within a unit test as inputs and outputs. So really, I have this block, this unit, where I don't really want to think too much about the internals. I just want to think about my inputs, which in this case are two values, A and B. And I want to think about my output, which is in this case a return value. And now I can start kind of thinking about verification. So it's an addition function. So the most basic test would be, very obviously, I give it two positive integers, and I make sure that the thing I get back is also a positive integer. So I verify that. My mic is kind of falling down here. I verify that my two inputs go in, that they add and they return the proper value. As I get more complicated, I can start adding in negative values, making sure that if I add two negative numbers, I get a negative number back. But those are kind of the basic outputs. What I can start doing to make it more interesting is I can start also saying, okay, what happens if I provide a integer and a float? Or what happens if I provide an integer and a null value? You can start going through all of these possibilities, and where the nice thing here is there isn't really necessarily a wrong answer. What you're going for is you're going for a definition. You're clearly defining the behavior of your system. So you might say that it is completely valid to say that your addition function, if it takes an integer and a float value, should return an integer. Or you could say it should return a float. But one way or the other, you have to define that behavior and be clear about it. And unit tests help you kind of do that. The other interesting thing is you can also kind of start working through your error cases. So what happens if I put in an integer and a string? This is Python in our example here. So I don't have types defined. I could put in a string for B and it would still try and run this line. What should the behavior there be? And it might be an error. It might be that your code needs to be rewritten so that it converts it into an integer for you. But the cool thing about unit tests is they kind of force you to think about those problems. Additionally, what makes them even more interesting is unit test libraries. Generally, you can get extensions to them that allow you to have the library do it for you and think about, you just tell it, hey, this is a thing that's supposed to take two integers and return an integer. Find all the weird edge cases for me. And it can go and enumerate all those possibilities and run them for you. And unit tests are super light and super tiny, so you can run hundreds of them within a second or two. So you can very quickly go through and have a wide array of tests for your function and be very certain about the way it operates and the way it functions. Next, we have component testing. So let's talk about what a component really is. There are different ways of defining it. I think the easiest way to kind of think about a component is it's when you take your code, the released artifact that you end up with. What that looks like, it's going to vary from project to project. But some examples might be if I am writing a web page, my web page is my component in this case. Or if I'm writing an API, my released API that I run at the very end of the day is my component. Or if I'm building a app, the app that I install onto my Android or my iPhone would be my component at the end of the day. And this can be more granular depending on what your system looks like. But the nice way to look at it is the thing I run, that once I have all my code written and I'm actually executing, that is kind of my component. What this kind of lets us do now is we've kind of moved on from thinking about the individual nitty-gritty bits of code that we're working with. We're not really so much thinking about functions and classes anymore. We're now thinking about functionality. We're thinking about the user experience and how I interact with the thing I've just written. For our dummy example here, let's work with a login page. So username, password, submit button, and how should I interact with that? So this allows you kind of to start enumerating user behaviors. So one example might be, okay, I have a registered user. I want to log in with my correct credentials. I should be taken to my profile page. This is a very obvious happy path is what we call these. So this is the normal, like everything went well, nothing happened incorrectly kind of scenario. But I can have other ones where, for example, I do have a registered user, but I fat fingered my password and I typed it in wrong. In that case, we enumerate that I want to have an error message displayed, and I want to make sure that the user is notified. And then another final examples, I don't have a registered user, but maybe I'm trying to get into the system anyway. I'm typing in random usernames, trying to get whatever I can get, and I get an error message asking, again, telling me that that's incorrect. This lets you do a couple things. One is that you can kind of verify that when your thing is running, it behaves the way you think it does. It's one thing to have bits and pieces of code that you've tested individually. It's another thing to have them strung together and making sure that when you do a thing, it actually follows through and does everything you expect. It also lets you kind of start defining and thinking about things from a user's perspective, and that can help you kind of better understand the way that people might use the thing you're building. But yeah, this layer is all about describing behavior and the outputs of that behavior. So that might be a user response, like the response you send back to user in terms of the notification. This might be files getting written to disk, if maybe you're making a Word application or a notepad or something. But it's all about the inputs and outputs of the actual behavior and the business value that the thing you're building provides. So at this point, we've validated the individual functional code. We've validated the functionality of the thing we're building. The next thing is we want to start validating how the thing we're building interacts with other parts of a larger system it might be a part of. So going back to our login example, a very common thing is I forgot my password functionality, right? And to do that, I need to be able to send out an email usually. And there's completely the option that you have within your login application built out the entire email functionality yourself, but more commonly, it's not unusual to have a third-party service that would do that for you. So an example of integration test would be kind of validating that interaction with the email service. I'd maybe have my thing spin up, connect to the email service, and I would validate automatically that when I do go through the steps to do that email service that forgot password functionality, that the email service is in fact connected to, notified properly, and the response is sent. So that's a type of test that I would want to do and be able to verify consistently over and over again. And integration tests kind of make that a little bit easier for me. It's worth noting that with an integration test, I'm working with a real service, like the actual email service itself usually. And that's worth noting. We'll come back to that later about why that's worth calling out. Another example might be my user DB. As a login, I have a DB full of users. And granted, the database is something that I've built, but it's still a thing I need to be able to interact with. So verifying that my login is able to make those queries to the database, does know how to interact with it, and does know where everything is when it needs to actually do its functionality, is worth validating and making sure that it actually functions. Um, Here we're less interested in overall in the behavior. We kind of, when we get to this point, already know the behavior works. We're more interested in just making sure that our stuff can talk to each other and that we're not going to have problems once we deploy everything and get it running with it talking to the stuff it needs to talk to. Last on the list is our system level tests. So here I have some kind of system. So this can be an actual operating system, so like Windows, Linux, or Mac. It can be an Android system. It can be maybe Amazon Web Services. Maybe I have I'm just hosting it on a cloud platform of some kind. Where your system really is doesn't matter. The really distinguishing point here is it's the place where you expect your thing to run at the end of the day. And it's worth doing this because when I have my component and I'm running it on my dev box, there are dev tools and libraries and a bunch of things on my system that are available to me that are there to make my development life easier, but they don't actually guarantee that they'll be able to run on somebody else's machine. And this is actually a very common problem that you run into of the works on my machine type bugs, where it works completely fine on your dev infrastructure, but the minute you try and hand it to somebody else, it breaks. So this kind of test helps you kind of avoid those kinds of problems. Usually it involves spinning up some kind of system in a virtual machine or in some kind of other environment that is not your local box. You take your component, you make sure that it installs and can interface properly. And in this kind of setup, usually you would validate things that really interact with the system. So maybe, can I connect to the network properly? Can I hit the internet if I need to? Can I read and write files to the right places? Do I have access to what I need to be able to do my job as a component? And do I have access to other applications on the system? So if there's a database that I need to talk to that is on this system, can I talk to it? If there are drivers, or if there are, maybe I need to have mouse connectivity. Those kinds of things are things I can validate at this layer. So those are really the layers that we're interested in for the sake of this talk. So let's go back and kind of look at our pyramid real quick. And the reason that this is shaped like a pyramid is actually not coincidental. Usually when you're doing these types of tests, what you find is you'll end up with a lot of unit tests, slightly less components, slightly less integration, and slightly less system level tests. And the reason for that is unit tests are super light. They run very quickly. But once you start going into the component integration and system layers, you now have overhead that you need to get over. For component testing, you need some kind of libraries to be able to interact with your component for the test. So if you're working with an API, you need some API libraries that will go and call out and talk to the API. If you have a web page that you want to test, you need to open up a browser and have the test code go and interact with that browser, and it's just heavier overall. At integration, you go even higher with that, because now you need to also interact and talk to other real world services, and it kind of comes to a peak with a system level test where you have a whole operating system that you need spun up. So generally speaking, there's this concept of you want to test at the lowest layer possible. So if you can validate something at a unit layer, do it there if you can. And if you can't, component is fine. If you can't, integration is fine. And your worst case is a system level test. There's also the concept of failing fast. So generally speaking, because of the spin up and because of the time to execute, unit tests will fail a lot faster, and you'll know you have a problem way quicker than if you were at a component integration or system level test. Those will take longer to run, and so it's going to take you longer to know that there's something wrong. So if you have a 100 unit tests, they will run faster and tell you there's a problem way before 100 component tests will run, or even 50 component tests will run for that matter. So the lower level you can go, the better. The other thing you start to realize as you kind of go through these is that there is overlap between the various test layers. So I might have one system layer that is actually a through line between an integration, a component, and multiple unit layer tests. And that overlap is actually fine. Generally speaking, you want some representation of your lower layer tests in upper layers, even if that is just kind of coincidental. So, for example, if we're kind of going through our addition example, maybe it's part of a calculator. So the unit layer will have a bunch of tests verifying that add functionality, but I still want some tests at the component layer making sure that the addition works once the application is running completely. I may also want some validation at the system layer to make sure that once it's been installed, that addition does still work on an installed system. So you will see some repetition of your tests throughout the layers. Just don't go for try and keep them to as lower layer as you can, and keep the duplication to to a single class of test, as opposed to having 50 tests that validate addition at the component layer. So with this, we kind of, when we there was something I mentioned about the component integration layer that's a little bit weird, which is the component layer, once the entire application is spun up and you want to validate functionality there, but some of that functionality relies on external services. And we said that we validate those interactions with external services in the integration layer. But that would mean that any component level test that had an interaction with an external service would now need to live at the integration layer. And that, again, kind of violates our rule of trying to test at the lowest layer possible. So to get around this, we have the concept of what's called a test duplicate. So again, I have my login and has its connections to the email service and the user DB. The idea of a test duplicate is I replace those out at my component layer so that instead I'm interacting with versions of them that I have written that are more conducive to testing. That means they're not necessarily full featured, but they're featured enough that I can plug them in and they can replace my real services for the sake of testing. And I can use them to validate stuff with my component that I care about. So for an example, in my user DB, I might have a database that is identical but empty. And here I can pre-populate data on a test-by-test basis with the data that would be interesting for that test that can help me put myself into an interesting state that I might not have with my real-world database. So maybe I want to test what happens when my login tries to interact with a user that has corrupted data on it for some reason. Or I want to test a specific type of username without necessarily having to create a bunch of test users in my real world database. Test duplicates allow us to do that. In this case, what I just described is kind of what's called a fake, which is a test duplicate that is almost identical to the real world thing, but is designed to be a drop-in replacement that you can do stuff that you wouldn't want to normally do with your real world interaction. Another type is called a mock. And mocks allow me to define behavior. So for example, I can make a mock of my email services, and I can instead say, hey, normally when you interact in this way with the email service, you should get back this response, but I want you to show me how you respond if the email service is down for some reason and returns a 500 error or returns a 404 error on the request. I want you to, I expect the behavior to be this. I want to prove that. And so doing getting the email service in the real world to respond with a 500 or a 404 is extremely difficult, especially if it's not something I've written myself. So instead, I make something that looks and behaves kind of similar to the real world thing. I have my component point towards that, and I have it interact with that for me instead. And I can define the behavior on the fly and have it break or respond in weird ways or respond in a way I don't expect, and be able to verify some edge case behavior that I might not be able to see otherwise. It's also worth noting that these concepts exist at the unit layer as well, and they're used for similar things, just at a more fine-grained level. You can find some good literature on that already. It's been written and by a lot of people, and there's a lot of concepts discussing it. But at a unit layer, for example, I might use a mock as a dependency injection point. If any of you are familiar with that, I can inject a mock and have it be part of my execution, and then have the mock behave in specific ways. So these test duplicates can exist at multiple different layers. You'll usually see them at the unit and component layer for the most part, though. So with that, I want to talk also about a concept, the concept of test-driven development and behavior-driven development. So test-driven development is probably something you may have heard before. This is basically the concept where instead of writing your code first, you write your tests first and then write your code after. And there's a couple reasons you might want to do this. This forces you to start thinking about your interfaces of the code you're writing. Does the way I'm asking my code to interact with other parts of the code make sense? Does the thing I'm asking my function to do make sense? Is it maybe too big? Am I asking too much of it? These are kind of things that come out when you start writing your tests first. It also forces you kind of think about how your function might respond to failure, all these kinds of things. The other concept is called behavior-driven development. So this is usually going to be more at your component integration layers. And this is talking more about how should my system be behaving? And you write those types of tests out first, and then write the underlying implementation afterwards. So this gives you, this makes you think about what your thing does before you start thinking about how you're going to go about writing it. And that way you can also interact with your peers or your coworker or somebody in your class and be like, this is what I think it should be doing, and they can give you their feedback. We kind of sometimes take it as a given that the solution is obvious, and that the way you solve a problem will be obvious. But it is more often the case that people have different opinions on how to solve one single problem. So being able to describe that up front before you start working is extremely useful and can save you a lot of time down the line. But the common through line between these two things is you're designing first and you're coding later. Test-driven development and behavior-driven development are common best practices that a lot of companies do strive for, but in practice it's very difficult to do because it requires kind of a level of self-discipline of thinking about writing your tests first, which is maybe not going to be as fun as just jumping in and writing the code that you think would solve the problem. So kind of to summarize everything and to wrap everything up, what does this kind of get us? So this gets us assurance that our code functions the way we expect. So my functions and my classes and my objects are all operating in the way that I've enumerated and described. I've clearly defined a set of functionality that has been vetted. So I know not only that my code works, but the features it provides work in the way that I think they work. I have now proof that I can interact with the service and that my component can interact with services and systems that it depends on. So it can be installed onto the operating system. It can talk to the things it needs to talk to. I can have a high level of confidence that if I take my project, hand it to someone, and tell them to install on their machine, it will work. It gives me a nice, and this is kind of the thing that a lot of people maybe might think about, is it gives, if I hand my code base over to somebody else, they have a nice solid set of examples both at the code level and at a functional level of what they're looking at. They have an introduction to how the code base works, to how the product that I've given them works, what features it has, and what behaviors it will operate under. And that allows people to kind of more easily jump into a code base and also more easily find parts of the code base that they're interested in. Um, and finally, I have really fast feedbacks on when I have bugs that surface down the line. So not only if because as I add more features, um, I'm going to, there's always a chance that I might break something in a different part of the system. And this allows me to not only know that I broke something, but because I've done this tiered model, I can very easily know where the failure is. Even if I've missed something at one layer, there's a good chance that the next layer up will catch it for me. And then I can not only go and be able to kind of narrow down where the bug might be and find it, but I can also now know where to add in my missing tests to help me make sure I don't miss that bug in the future. And lastly, and this is the really kind of amazing thing about this, is with the exception of the unit layer, everything I've done at the component integration and system level is behavior driven. So what that means is I can decide, let's say I've been coding my project in Python for the last couple months, and I've gotten to the point where I'm realizing I need more performance out of it, and I need to redo my project in a different language, let's say Go. Um, I will have to scrap, let's say I have to scrap my entire code base to do that. I will lose my unit tests, but I can rewrite the entire project in Go. And as long as the features work the same way, I don't have to rewrite my component integration and system level testing. Those can stay in place. I will need to rewrite my unit testing and rebuild that base layer, but the rest of it can kind of keep going and keep being used because it's designed around the behavior of the system as opposed to just the nitty gritty. With that, that's everything I've got. I think we probably have some time for questions if people are interested. If not, again, let me actually roll back down to the beginning here. Those are my contact details. Feel free to reach out if you have any questions, or if you want to see something like more specific, or you want to see how this kind of works in a real world project. I'm happy to kind of walk through that. Yeah.
It looks like we already have a couple questions in the Q&A box, and maybe a few more will come in.
Yeah, let's have a look. Okay. Yes, my slide deck wasn't tested. No, I think what actually happened was I copied and pasted a slide, and it must have accidentally deleted it. I should have gone through and validated my slides. You are absolutely right. How do you write unit tests before writing any of your code? What's the best way to think about this? So when I'm writing my code, what we're actually doing is we're saying I need a function that solves this problem. What writing your tests first makes you do is thinking about your problem first, then write what we call an interface for your function. So what you're writing here is, for example, let's say, again, let's go back to my addition example here. So if I'm not doing this, I know I need a feature that does addition. And I can think about what that would look like from like a functional perspective from the interface. So here, all I would really need to say is I write a test that I know it's going to be an addition function, and it's going to take 2 parameters for addition. And I can kind of define that up front. And I don't need to know how I'm necessarily implementing that at the end of the day. All I need to know is that it's going to take 2 things. It's going to return 1 thing, and I can write the tests around that. And now I can start filling in the details later. And this is what we call red-green. So you start by writing a bunch of tests that start off by failing, and then you go and fill in, you start writing the code to make those things turn green. I'm not sure if that's abundantly clear. Let me know if that doesn't make sense. I can come back here and try and do more detail. And again, I'm always happy to give more examples down the line if you would like to reach out. When you're testing your application at a system layer, do you use Docker, Kubernetes? That is an option. So one way of looking at this is let's say I'm doing a Docker example. So I have a Docker container that has all my stuff in it, and that is my component. So when I'm testing it locally at the component integration layer, I'm spinning up the Docker container and I'm using that for the tests. And then when I want to go to the system layer, I'm taking that Docker container and I'm dropping it in Kubernetes. And then I'm making sure that Kubernetes can pick up the container, spin it up, and is running it properly, and that let's say I'm on AWS and I have an EKS cluster, I can like make sure that that container can properly connect to an S3 bucket that it needs to talk to or something. I hope that gives you some clarity. Like the system level test is kind of like, where is this going to end up at the end of the day? Let me throw it in something that is comparable and make sure that it runs there, even though I know it runs on my local machine and it works fine there. So next one, you're saying that full TDD isn't realistic. What level of testing would you expect at various sizes of companies, from startups all the way to large companies? I'm not going to say TDD isn't realistic. I'm going to say TDD is hard. It requires a level of self-discipline, and it requires you to really have the self-control to sit down and be like, I am going to sit down for an hour and write a bunch of tests that are going to go red initially, before I go and write any useful code that will actually get me towards my goal. As far as what level you can expect, I'm going to say that is purely cultural. So I have worked at small companies that are able to do TDD. I've worked at large companies that were able to do TDD. I've also worked at both of which that cannot do it. I should point out, I've worked at Cisco. So like I've worked at really big companies, and like it's really more of dependent on the culture and the team you're working with, along with how much of a priority testing is for that given organization and which team you're working on. I want to say that it's always a realistic thing that you can accomplish if you're given the breathing room to do it and you're willing to make it a priority. And I personally believe that the benefits of doing so far outweigh the cost in the long run. Can too many tests be cumbersome, and how do you decide how many tests to use? That is a really fucking good question. Sorry. Yes is the short answer. I think you need to kind of do a cost-benefit trade-off on what you want. I think at a unit test, the answer is almost always it's worth doing, because you can't really have too many of them. They're so quick, they're so small that you can really get away with writing thousands and thousands of them. Really, the problem that comes down to maintainability at some point for unit tests. At the component and integration and system test layer, I would say system testing, you want to have minimal, like as few as you possibly can. They're heavy, they're slow, and they're brittle. That's the thing that I forgot to mention, is as you go up that pyramid, there's a higher likelihood that there'll be an external factor that will cause your test to fail. So at a system level, maybe your operating system is just being wonky, or integration test, your external service is misbehaving and causing your test to fail. And it's not a problem actually with your component, it's a problem with something external. So I would say like that's the kind of the goal of pushing everything down to the lowest level possible, is to get around that cumbersomeness and the chance of false negatives. How you decide is really, I think for me, I look at these as a long-term investment. So would this be useful to know about if something goes wrong 3 months from now and I've totally forgotten about how this feature works? Another way to kind of look at it is there's a bug-driven approach to it, of I do my best effort, and then as bugs show up and I have to fix them, I make sure that each bug I fix has a test attached to it, so I can constantly know that down the line that type of issue doesn't reappear. I see your email. Are you on LinkedIn? Yes, I am. I am less likely to reply on there, but feel free to reach out if you'd like. can you explain the split between DevOps and software engineers? Hypothetically, there shouldn't be one. Realistically speaking, your DevOps engineer is generally going to be more ops focused. So they know their AWS a lot better. They know their tooling. They know their CI/CD a lot better. They know Jenkins, Travis CI, some kind of tooling. They're really spending a lot of time around reliability. So monitoring of the system, being able to get metrics out, knowing how fast things are going. Um, they're there as kind of a secondary support. In a perfect world, and this really depends on company to company and your team you're working on, but in a perfect world, you should really have that be kind of an embedded part of your engineers. Like, your engineers should know how to do all of that, but some companies prefer to kind of have that split of having a DevOps engineer that's just dedicated to that type of work, that they can rely on, as opposed to trying to get a software engineer to be spun up on AWS, for example, which is a large investment of time. Like, or like having software engineers spend time building dashboarding or alerting. They'd rather have maybe an engineer who's dedicated to that. And that's kind of where DevOps sometimes comes in. But hypothetically, they should be about the same. I know most of the DevOps I've worked with do have a development background. Although I do work with, for example, one engineer who he started in operations. So he started in like server rooms and whatnot, and then moved into DevOpsy roles, if that makes sense. Why did you choose to specialize in testing and DevOps? So I think this is something that a lot of people run into when they're starting their career. You don't really pick your career; it kind of picks you. Um, I'm I will point out that I have a development background. I can code in Ruby, Python, Java, C Sharp, C++, JavaScript, you name it, I can probably work in it. Um, I happened to be at one of my first jobs. There was a gap for people who knew how to test. I happened to get a really good mentor who taught me a lot, and that kind of led me down the path of testing, and I realized I really liked it. There's something very satisfying about being handed somebody else's work and being able to, like, yeah, so you messed up in these 8 places, go fix it. And from that kind of, there was a natural overlap between that and DevOps. I found myself when I was working at Cisco, um, building a lot of pipelines, building a lot of infrastructure around my testing that would make my testing more efficient. And it kind of leaked into the DevOps side of things, which is how I kind of ended up on a DevOps role as well. I would definitely say testing is still my first love, and it's something I'm still very passionate about. But DevOps is also interesting, and it's kind of nice having that overlap. Any other questions? Cool. Awesome. Well, thank you guys so much. Again, feel free to reach out if you have any questions or you'd like to see. I know this was, again, very high level and non-technical, but if you would like to see an example of like a project with this stuff in it, feel free to reach out. I'm happy to kind of walk you through that and maybe help you incorporate that into your own projects if you're interested. Cool.
All right, I want to thank our speaker and all the attendees with their wonderful questions. Have a great evening, everybody. Bye.